Hello, APBIO. In this video, I'm going to talk about the RK selection theory. So we're here in your notes. And the RK selection theory refers to the reproductive strategy, so the collection of phenotypes that a particular population has, species has, that are related to a successful reproductive strategy in a given environment. And it's called the RK selection theory. This, I think this is Paul Anderson talking about it in the Bozeman. You can watch that video if you want to. But the RK selection, it's called the RK selection theory because R refers to growth rate in our population growth equations that we'll talk about tomorrow in class. And then the K refers to, as you recall from the previous video, to carrying capacity. So it refers to the theory that organisms are going to either have adaptations, that physical adaptations and physiological functional adaptations, where they're going to either have a reproductive strategy that makes them grow really, really fast in environments and produce a ton of offspring. And then there's a high mortality of those offspring, or there's all kinds of strategies where there's not as many offspring produced, not as many individuals, but there's a much lower death rate. And those organisms are going to live right up by carrying capacity. So they're going to have a logistic shaped growth curve. So first of all, let's define the RK selection theory. It's this idea, a theory, a claim that there's a selection of combinations of traits within a species that are a trade-off between quantity and quality of offspring. And in this particular case, in this theory, the traits that are referred to are the traits that have to do with reproductive strategies. So let's talk about it in terms of a couple examples to see if we can have it make sense. There are two categories of organisms. And actually, by the way, you'll see in a minute that it's not as black and white as either R or K. There's many organisms that live in this gray area in between. They might have some qualities, some characteristics of an R strategist and some of a K strategist, and then they fall somewhere in between. So it's not really black and white. In any case, over here I've got listed R strategies that an R strategist would employ, and over here I have K strategies that a K strategist would employ. So let's talk about R strategists first. An example of an R strategist is, for example, frogs. So they're going to grow at an exponential growth rate. Often, R strategists live in somewhat unstable environments where there'll be a change in the environment, and then all of a sudden there's these available resources that weren't available before. And so these R species are going to have adaptations that are going to allow them to grow at really, really, really fast growth rates. They're going to, bam, smash through. This red line right here is carrying capacity. They're going to smash through carrying capacity, and then they're going to hit up against a bunch of limiting factors. And then their population is going to come back down. They're going to do all over again. Now, organisms that are K strategists, they're going to go through a period of time. They're going to follow a logistic growth curve. Here's a logistic growth curve right here. And the rate is going to plateau. It plateaus at carrying capacity, which we call K. And that's why we use a capital K, because it's a capital K in all the equations that we use to describe populations and predict population growth, whether it's positive or negative. And these organisms are going to often grow in more or thrive in more stable environments. So let's compare the two. I'll go back and forth to see if we can compare the different characteristics of these organisms. R strategists are going to be small, simple organisms. So frogs are small. They're not that simple, but they are relatively simple compared to more complex organisms. We also over here have R strategists. Bacteria are R strategists, and all the single-celled organisms are R strategists. So they're small and simple, as opposed to K strategists are going to be larger and more complex. Over here in K strategists, we have like elephants They're an example, sorry, I should have put that in here. An example of a case strategist is an elephant. Now, R strategists, I'll go down quickly down the R strategist just to try to not confuse you. These are going to be subject to predation. So they're not going to, their actual physical structure, they're not really that well protected. They don't have a lot of body armor. They don't have protective strategies, so they get eaten a lot. They also have a relatively short lifespan. So they're going to like really go hard. They party hard and then they die. They're gonna, once they're born, they're gonna be able to almost immediately have babies. And they have a very high fecundity. Remember from the last video, fecundity means they can have a lot of babies. And when they have babies, they don't care about them at all. Sometimes they even eat their babies. So for example, like spiders eat their babies. They have a lot of babies, but they eat them. Which is awful. You cannot eat your own babies. Anyway, so these are all our strategist, our selection criteria. Over here in K strategists, like I said, these are larger or more complex organisms. They're very well protected, which means they have like big giant teeth, or they're really fast, or they have strong armor, like a tortoise, right, has a shell, or an alligator has a thick outer skin, or I mean, I guess it's called skin, or scales, I don't know what they're called. Anyway, or platy, anyway. Or like they have, they can reason their way out of danger. They have a delayed sexual maturity, takes them longer to mature sexually. So they often need to be cared for. We'll talk about that in a second. They have a low fecundity, which means they don't have that many babies. Humans, elephants. I mean, elephants, their gestational period for elephants, the time that the fetus is in the womb, is 2 years. Can you imagine being a mother elephant? That's awful. Anyway, and then they have a high offspring investment. That's related to a delayed sexual maturity. So the young, the offspring, the parents take a lot of care of the offspring. So there's a much lower infant mortality rate, or offspring mortality rate here in the K strategists as compared to the R strategists. Okay, that's it for our K's selection theory. We are going to use some math to talk about modeling populations in class on Friday. I hope that was helpful.